Hey everyone, my name is Corel, and today we're going to be doing another tutorial, this time on advanced cannons. Advanced cannons, as a general theme, they have a lot of utility. They have a lot of projectile speed, which makes it very easy to hit things with them, and they're kind of the gold standard for just the amount of damage that they deal over time. They're pretty easy to build a basic cannon, but there's a lot of complexity that goes into making a really well optimized cannon. That's been made a lot easier with some of the recent APS patches, so we'll take a look at some optimized designs in another tutorial. For now, I'm just going to go through the overall construction and all of the pieces involved in building an APS. But before I get into the pieces themselves, I want to go over some general concepts first. First off, APS has designable shells, much like we had missiles that you could design the individual missiles with all their components. APS, or advanced cannons, have designable shells that allow you to customize them to suit the gun that's firing them, to suit the vehicle that's mounting the gun, or to suit a specific type of target. Second concept we'll be dealing with is gauge. Gauge increases the diameter of the shells and the diameter of the barrels that you're going to be using on the gun. A large gauge will lead to slower cooldown and reload speeds, but generally each shell will deal more damage on a hit. So gauge is no longer a really good indicator of damage, or DPS I should say. Gauge used to be a very good indicator of DPS, with larger gauges doing more damage over time. However, that's no longer the case. A recent patch has kind of rebalanced this, so we'll be taking a good look at a variety of different cannon gauges as we go through this series of tutorials. The next concept to keep in mind is cooldown. Cooldown is influenced by the projectile length, and it's countered by cooldown reduction and barrel count. It's also increased by gauge, so the larger gauges will have more cooldown per shell. We also have reload rate, which is influenced by the shell feed method that you're using. There's 3 different types of those, kind of 3.5, we'll get into those later, but your reload rate is affected by the gauge, as well as how you fit your ammo input feeders here into your cannon. So we've also got recoil. Recoil will reduce accuracy if you do not have enough recoil absorption. That's pretty straightforward, and there's very easy ways to mitigate that. Moving right along into our components, first off we have the advanced firing piece. This is your general run-of-the-mill vanilla controller unit for the cannons. So this is going to be what actually fires the projectiles. The front side of it is where the projectiles come out. The back side is where we can connect our components. We can connect some components to the sides and top and bottom of this, but in general the front and the back are the interesting bits. Next component is the 6-way connectors. These are not terribly useful, and I tend to treat them as pretty much dead space within a cannon. They're fairly fragile, you just don't really get a whole lot of value out of these. For the most part, gauge increasers and coolers that we're going to get into later are going to do what you need without the need for a 6-way connector. So yeah, stay away from these. Next up we have the ammo controller. This lets you create a customized cannon shell design. So these are completely independent from the APS firing piece. They can be placed anywhere on the vehicle. And then you have the ammo customizers that allow you to add components. You can hit Q on this to select your shell components. We'll be doing another tutorial that gets into what each of these components is good for and general shell design. But for now, you have an ammo customizer that gives you 2 components and an ammo customizer that only gives you 1 component. So that's it for the ammo customization, and we can move right along into our gauge mechanisms. The first gauge mechanism is a gauge increaser. So this goes straight behind the APS firing piece, and you can extend these in a line however long you want. However, there's a limit of 8. If you have a 9th, it doesn't do anything. So at 8 of these, I have a 500mm shell. If I add a 9th, I still have a 500mm shell. This even keeps the same value if I increase the number of barrels to maximum. Now I have 650mm barrels. If I add a 9th one of these gauge increasers, I'm still at that 150. So you cannot increase your gauge beyond 8 of these. Next is the gauge cooler splitter. These are basically a cooler that will reduce the cooldown of the gun. So each time it fires, it generates a certain amount of heat on the barrel that fires it, and the cooldown is going to, cool down faster. It's going to remove that heat faster. So the APS firing piece comes with a certain amount of cooldown reduction built in. These add more, and they also split the line. So I can make this line much shorter and more compact if I was to, say, put a splitter right here, and I can put another couple here, and then I can start putting 4 of these back here on each side, and I've got the exact same amount of gauge increase that I had before. So yeah, these splitters are super helpful and are really required when you start dealing with any sort of complex gun. Next up, we have the gauge cooling unit. Similar to the gauge cooler splitter, this gives you cooldown reduction, and it just gets placed in these same lines along with everything else. Next, we're going to look at recoil absorbers. We will look at these all as one block. Even though they are different blocks, they all have linear values, so you're not really getting anything more out of using a larger block other than just its general durability. So the recoil absorber is going to give you a flat amount of capacity for recoil and a flat amount of recovery rate for recoil. And your recovery rate will help counterbalance guns that are firing constantly. Your maximum capacity will be useful if you're doing a burst fire gun. So you just want to make sure that your recovery rate and capacity are suited to the type of shell and cannon that you're firing. Next up, we have the ammo input feeder. Ammo input feeders can feed in 3 different ways. They can be attached directly to the firing piece, and they will load a shell directly into the firing piece that they're attached to. They can load into autoloaders directly that do not have clips on them. They will load one shell into the autoloader at a time. That autoloader can then load the shell into the firing piece. Or they can load shells into ammo clips directly, or into autoloaders that have attached clips. And in either of those cases, it will feed shells into the clip, which then feeds it into the autoloader, which then feeds it into the firing piece. Regardless of how you have the ammo input feeder attached, its intake rate from the ammo customizer or the ammo controller will always be the same for a given gauge of shell. You cannot increase the rate of input from the ammo input feeder. All you can do is add more of them. You can see they're fairly expensive here at 50, and you're going to need quite a few of these, so keep things as fairly balanced as possible just to avoid having an overly expensive cannon. Next up, we have autoloaders. These come in 2 primary variants. First, we'll go over the regular autoloaders. These are increasing in length as you go down the list here, and these are basically just going to feed shells from themselves into, or any attached clips for that matter, into a firing piece. They do so much more quickly than a simple ammo intake can feed shells directly into the firing piece. So if I put 4 intakes on the APS firing piece here, that is going to be slower than putting the equivalent 4 ammo intakes onto a pair of autoloaders, or even a single autoloader. If you mouse over the autoloader here, you can see it's got some state information there about how many shells are loaded, whether it's ready to fire, and the loading time modifier. That can be a good or a bad thing. Basically, the loading time modifier is telling you how long it's going to take to load a shell, and that can be modified by a few different factors, not least of which are clips. Before I go into clips, though, I'm going to go over the belt-fed autoloader. The belt-fed autoloader is basically the same as a regular autoloader, but it can only mount clips on one side of it. It can have ammo input feeders attached to the sides of it, the same as before, but it cannot reload while it's firing. That's the primary difference between these two. The regular autoloader, you can reload the clips attached to it as well as the autoloader while the cannon is firing. With the belt-fed autoloader, you cannot. Interestingly, the belt-fed autoloader doesn't actually need a belt. It doesn't need a clip. You can actually attach ammo intakes directly to the belt-fed autoloader. It will load a single shell into itself, and it will fire that shell. This is generally a bad idea though, because you're probably going to want several ammo intakes in order to feed enough ammo into a clip to keep this thing firing at a reasonable rate. Otherwise you're going to have fairly lengthy reload times in between each shot, and it's just really not any better than using a regular autoloader. When looking at these, you can hit Q on an ammo intake, and you can select a controller here in order to either edit the shell or pick the controller that you want to fire a shell from. You also have buttons here to control how your intakes deal with those shells. For instance, I can disconnect all intakes from this ammo source. I can select an unassigned intake so I can see which ones aren't assigned a shell yet, or I can just toggle through them with the next intake button. When I'm satisfied with the intake that I've got selected, I can pick the controller that I want, and I can assign all unassigned. I can force all intakes on this specific cannon to use this ammo source, or these are pretty self-explanatory. Moving along, we have the ammo ejectors. These both are the same component. The main difference is what direction they eject ammo in. So the ammo ejector is going to basically detect damage on itself or its attached autoloaders or the clips attached to said autoloaders. And then if any of those are damaged or destroyed, it's going to take all of the shells in the attached system and it's going to dump them straight out this square chute at the end. The other variant of ammo ejector will dump them out the square chute on the top. So just keep in mind the ammo is going to come out that square end, whichever the square end is on. The ammo ejectors are great for cannons that are going to be mounting, say, flak or high explosive shells or anything like that, just to keep the entire cannon from self-detonating the moment it takes a single piece of damage. However, as you'll note here, these ammo ejectors are not connected when I connect them to a belt-fed autoloader. They can only be connected to a regular autoloader. It's another disadvantage of the belt feds, and one that makes the belt feds relatively difficult to use, or rather painful to use, with explosive projectiles. Also keep in mind that the shells that are ejected from these are live, and if they hit things, they can do damage. Again, that makes explosive shells dangerous because if you eject them straight back into your own vehicle, they're going to explode. This is a bad thing. Last up here we have the ammo clips. These clips correspond to the length of the autoloader that they need to be attached to. While you can have a longer autoloader with a shorter clip on it, I would not generally recommend that. It's kind of awkward. In fact, it's very awkward. You can only fit the ammo in that matches the clip size, and just doesn't work real well. As far as the differences between these two rows, or columns rather, the left column is the open ammo clips. These are great for testing purposes, they're great for aesthetics, but they have a lower armor and health, or rather just the armor, than the solid ammo clips. That's primarily just to encourage you to use the solid ones, because the solid ones are much easier to render on your graphics card. So if you're running into problems with your ships rendering very slowly, or just the game slowing down when you have a complex vehicle with a lot of cannons and a lot of shells in it, just switch to the solid ammo clips and everyone will be happier. One thing of note here, these clips can be connected in all sorts of unexpected and unusual directions. If I was to go out here and let's just grab an autoloader, and let's make a nice 3 meter autoloader. This will fit nicely. So I placed this with the root of the block facing towards the front of the cannon. The root of the block is actually important. You can tell which end is the root by the part that has the extra pegs coming out of the end of it. Now, you might not think this will work, but oddly enough it will. If I put a clip facing out to the side, this ammo clip is connected. It will feed shells directly into the autoloader as normal. If I put another one out here, however, it will not. It can lead to some very unusual ways of Tetrising these together. Also of note, clips can connect to each other. In fact, they can connect to each other in very unexpected ways. Again, if I have the root of the shell block, or the clip block, connected to the end or the top of, or the root block of the other clip. So both of these are valid clip configurations. And that is really pretty weird. Yeah. You can do some very strange things with this. For instance, I now have extra blocks that I can connect ammo input feeders to that I couldn't attach these to if I was attempting to stack my clips normally. I can attach these up here. The ammo input feeders can only attach to the root block of a clip, regardless of that clip's length. So as you can see here, I've gone ahead and added all of the ammo input feeders that I could on this particular cannon design, or this particular clip layout, and it's kind of unusual, but oddly enough, it works. You can use this in some pretty unexpected ways, but often it's not very useful unless you are packing a cannon into a very tight, oddly laid out space, in which case, yes, this can actually do some good. There are some scenarios where you're trying to pack a cannon in around a chunk of armor or around other components where this can actually be pretty useful. So I figured I might as well tell you it's here and let you see what you can do with it. Also worth noting, the more clips that are attached to an autoloader side, directly to the autoloader side, note, not to each other, the more clips that are attached to the autoloader side, the better a loading time modifier we get. So right now we've got a clip on one side and we have a loading modifier time of 50%. If I was to connect another shell or another clip down here, this goes down to 33%. If I was to add more, they would get better and better. Worth noting here, there's also a few other interesting tricks we can pull. Autoloaders can connect to each other at the root block, similar to how we connected our clip back here. And the more clips that you have, up to 4, on a side, the faster that autoloader will reload. So this is actually a huge modifier and very worth investing in. If you manage to get an autoloader with 4 of these clips on here, the total reload speed modifier is 20%. That means the shell is loading 5 times as fast as it would otherwise. This sort of configuration can be hard to set up and pack into a cannon, but if you can manage it, it is well worth it. Moving on to the next series of components, we have mantlets. Mantlets come in a variety of types, and these basically modify the angle, both horizontally and vertically, that the barrel can aim in front of the gun. You don't necessarily need to have these guns on turrets. The barrels themselves can actually aim. The amount of angle that the barrel has that it can aim through is dependent on the gauge of the barrel. So the smaller the gauge, the wider the angle that the barrel can move through. So if I look at this tooltip on the Omni Mantlet, we can see that this gives between 10 and 30 degrees of both azimuth, that is horizontal left-right, and elevation, which is up-down movement. And the 10 degrees is on the high gauge cannons, and the 30 degrees is on the low gauge cannons. So also worth noting here, the gauge is dependent on the number of gauge increasers attached to the cannon, not the actual gauge per barrel. At least in terms of the mantlets, you will get that same movement out of the 150mm 6 barrel as you will out of the 500, both in terms of the movement range and the movement speed. High gauge cannons also move slower through these arcs. Moving through these quickly, we have an Omni Mantlet. This is 1x1 in size. That can be very important when we start talking about railguns. Moving quickly through the other types of mantlets, we have the Elevation Mantlet, which is also a 1x1 block. This gives less horizontal movement and more vertical movement. We have the Omni Mantlet, which is 3x3. This is a massive mantlet. This is very high azimuth and elevation. We have the Elevation Mantlet, which is basically the elevation of the Omni Mantlet, just a tiny bit better, but it's only 1x3 as opposed to 3x3. That can be, again, a huge advantage when you're dealing with railguns. Then there's the AA Mantlet. The AA Mantlet gives you only vertical movement in the upwards direction, and it doesn't give you hardly any azimuth movement, but it gives you a lot of elevation, between 80 and 100 degrees. So if you're building a ship-based cannon, this is almost always what you want, because you usually don't want to fire guns down into the water, but you do want to be able to hit aircraft flying overhead. The AA mantlet is very good at that sort of scenario. Also, if you have spacecraft that you're planning on shooting things below you with, these can serve you well if placed upside down. They are 1x2, which means they leave both sides and underneath available for railguns. Next up, we have barrels. These are really pretty basic. They add barrel length, and that's good for burning extra powder if you have gunpowder-based ammo types, or for adding accuracy for long shell types. That's really all these are here for, and there's really no advantage to them beyond that. You also have heavy barrels that are much more durable than the regular barrels. I would recommend using these wherever you get the opportunity to, but keep in mind they are very heavy, and since they're long, that can unbalance vehicles very quickly when you turret these and start swinging these around. You also have bore evacuators. These give you a cooldown modifier. They give you just a little bit extra cooldown reduction, but they are fairly fragile. So what you want to do is stick these at the end of your barrel, right near the tip of it. You don't want these back towards the mantlet, because if the fragile bore evacuator gets blown up, then, well, your entire barrel falls off, and that's not good. Next up, we have the muzzle brake. This gives you a 5% reduction in your muzzle velocity, which slows the shell down by 5%, and gives you a 10% reduction to recoil. So you trade off a little bit of projectile speed for a little bit less recoil. Next up, we have the railgun parts. Railguns are pretty straightforward. They require 3 different parts. They have the railgun magnet attaching fixture, which you'll want these around your firing piece. They have to be connected to the firing piece. Then you want the railgun barrel magnets in front of that. And if I attach, let's go ahead and attach a regular barrel here. These will go valid, the nice teal valid color there. And these basically are providing total maximum charge to the railgun system. So now I have extra maximum charge that I can apply to the shells loaded in here. And in order to charge that, I need a railgun charger. Now the railgun charger is a pretty straightforward component that can attach to any gauge increaser anywhere. So really, you can just stack these on a gauge increaser somewhere. You can also stack them on top of each other now. That didn't used to be possible, but that recent update added that ability. And these will charge your engine, or charge your railgun rather, from your battery power. Note, not your engine power. These are straight from battery power, which means that you need some sort of battery system on your vehicle as well. You can see here there's 216,000 total energy storage on the vehicle, and you can see there's 216,000 storage down here in the lower right, the total amount of energy available. So that is drawing from my batteries, not directly from my engines. Worth noting that when you have railgun components involved, if you hit Q on a piece connected to your cannon, you can go over here into the railgun tab, and you can set various different properties about how this railgun operates. Like if I want a minimum amount of battery power to stay always untouched, I can set that to like 50%, and the railgun will never draw me down below that, which can be useful if you're relying on electric engines and battery power for movement. You've also got a maximum energy per shot. Usually your shell will dictate how much energy per shot can be used, but you can also cap that in the gun itself. You can also use a percentage of the energy for an accuracy buff. This has pretty severe diminishing returns, but if you are building a railgun, 10 to 20% of this will always greatly improve your accuracy. Above 20% gets a little shakier in terms of the amount of value you get per amount of energy wasted, basically. But at least 10 to 20% will generally ensure that you have a much more accurate shell. The next component in line is the laser targeter. This allows an AI-controlled cannon to set fuses on your shells appropriately for the distance to the target and the time that the shell will take to travel to that target. So what this does, I can hit Q on it and set an offset time that will detonate a shell either sooner in the negative direction or later in the positive direction after a shell would normally hit the target according to what the AI has detected the target's range is. You can also set an offset altitude for altitude-fused shells, and you can set a safety distance that is the required amount of travel that this shell will drop before an altitude fuse will be set to go off. That way, if we're under 50 meters, say we're flying along at 25 meters with some of our bomber's wings damaged, and we drop a bomb from the APS cannon, that will go. It will not fuse the shell to detonate because it will have dropped less than the safety distance before that shell would go off normally. Basically, this is a safety mechanism in case you wanted to use these for bombing runs. Generally not too useful, and I tend to not even really like the altitude fuses all that much. Generally, you're best off with the offset time and a timed fuse, I think, rather than trying to use altitude fusing. Next in line is the follow shot predictor. This is basically used for manual aiming. If I was to try and, well, let's load a cannon shell into this cannon. Should have one here already. Yeah, so this will more or less try and show me where that cannon shell is going to go and how it's going to arc. So if I fire that cannon shell and then follow it, you can see it followed that path pretty quickly, or pretty accurately, until it got beyond the shell's maximum effective range and got slowed down a lot by drag. That's all of our cannon components. That's it for this tutorial. Next tutorial we will be looking at the shells and the shell design and design considerations for these and what all of these components do. And then we will have another look at some actual full cannon designs and just see what we can do with all of these systems. Thanks for watching. Hope it's helped.